want our bridge to push the force back up, flatten back out. So how would we make it so that our bridge would go back flat? What do you think, Kelly?
Put support in the middle.
Put support in the middle, but we can only use paper and tape. We're using the same materials as we used last week. What's your idea, Max? Okay. What's your idea?
It like caves in and maybe there's too much weight in the middle.
Yeah.
Or put them on the outside.
Okay, put some on the outside. Even out the weight a little bit. Okay, how would you increase your thickness? Holding it more? Okay. So, the guidelines are, and I will be handing out the tape again this time so that everybody gets about the same size piece of tape. So when you need a piece of tape, just raise your hand and I'll come over. So I need you guys to talk to your group members and come up with ways that we are going to, as a group, build our bridge. What is your idea in your head? How are you going to fold your paper? How are you going to roll your paper and flatten it? Kind of like the blueprints. You're going to make the blueprints in your head and you're going to talk them out with your table, okay? You have to work with someone, please. I think we have. You can work alone, that's fine. We'll have a group of 3, and then if you want to go over to the front table and work with, if you want to work with Max, then we will have enough. So right now I still want you to talk with the people you are sitting with. So Max, if you could talk with the people at the table in front of you and talk through how you could build a bridge, how you're going to fold it to make sure that it is strong. Yes. It's a normal sized piece of paper, but you have to have 8 inches in between your toes. It's a big river.
Like, I think we'd have to have it under. Oh, yeah. Can we cut the paper where they had it?
Oh, we're not grabbing supplies yet. Not quite. Yes. No. You cannot use the ruler for support. It has to be on the books. Does that answer your question? In the middle? What would you use for it?
We can like because of math, roll the paper, and then roll the paper. That's what we did in math. Sometimes I try to make it out.
That could work.
Yes!
Okay, let's come back together in 3, 2, 1. So based on what you learned from your bridges that you made last week and what you've seen other groups do from last week, and keeping those guidelines that we talked about, which are here on the board, if you need a reminder, how would you change your shape design to make it stronger than it was last week? What do you think?
Long enough, I would do the same folding this way instead of folding that way.
Okay. So folding in a different direction. Any ideas? Not quite? So how do you think that the bridge's shape is going to affect its strength? What do you think?
Because if it's just a plain piece of paper, like just laid out, it would not be sturdy because it doesn't have layers. It only has one layer.
Okay. So what else about the structure? Even if you fold it, the shape. How would the shape determine its strength? Help determine its strength. What do you think?
Like if it's just like this, if it's a circle, it's not going to be like sturdy enough because it's just there's actually layers that catching each other, so you're going to sturdy to the bacon strips.
Okay, can you guys hear okay over there? Okay, so if it's a circle, there's not going to be as many layers. So, like I said, we're going to get a little bit deeper into these bridge designs. So the science part of the bridge design is when we talked about that force. How we need that bridge, the force of those pennies and the force of the bridge to push against each other so that the bridge can stay strong while those pennies cross, while those machines go across. So it's kind of like a push and pull idea. So what are some other ways that we see forces when we're looking at bridges? In real life, what are some examples of force on bridges? Max?
Gravity.
Gravity, what do you mean by that?
Pushing the bridge, the forces down, so the bridge is pushed down the gravity.
Okay, okay. Yeah.
Balance.
Balance? Explain that.
So like if one side is more heavy and the other side is lighter, it might collapse on one side.
Okay.
It might collapse.
Okay. What are some other ways that we see force in bridges in real life? Yes.
The forces of nature, if there's like an earthquake,
Okay. Yeah.
on some bridges they have like things that go over the bridge. I think that might be the level of the bridge.
Okay.
It's straight.
What are some other ideas of forces on bridges? Maybe it's pushing down. We got a couple that are pushing up against the bridge. Or it might be one that's pushing down. Max?
Now it's like cars going across. There's like the Golden Gate Bridge. It's got like cars going across it all the time. So that's the force of
Cars.
people like get large bridges. They're pushing down.
People on those smaller bridges when they're walking across. Any other ideas? Think you have another one? What do you think, Katie?
Trains going back and forth.
Trains going back and forth. That might erode a bridge a little bit. So, why do you think it's important for engineers to take into consideration the force that's going to be on those bridges when they're building it? Alex?
Make sure, like, the resources used, make sure it's more stable resources, otherwise it'll collapse with the weight.
Okay. Katie?
So they make sure that the items that they use are good for the bridge because if they're not careful and a bunch of cars and pedestrians go on the bridge might collapse.
Okay. What's your idea?
To know how sturdy they need to make it and what items they need to use for it.
What items they need to use for it? Why would the items that they need to use for it be important? That can be anybody. Yeah, what do you think?
Because some are like sturdier and stronger than other materials.
Why would it be important to take that into consideration? Which ones are more sturdy?
Metal is kind of like really strong, so it can put on more weight than like regular paper and like fall down a little bit. And like wood, not.
So would it be better to have a wood bridge or like a metal or cement bridge for a train?
A cement bridge.
Why?
Because bridges, trains are more heavy, and they can hold things like they hold like coal and things like that are heavier and that weighs more.
So it's important to